Okay, it says solve the system of equations using the addition method. Now, we really call this the elimination method. Remember back when we were learning how to combine polynomials by adding and subtracting, but we didn't really like to subtract it, so we would always change it and make it possible to add it. Y'all remember that? Back when we were doing polynomials, anytime it was minus, we distributed that sign to everything after and made it addition. Well, systems of equations can be done the same way. It's called the elimination method, but most people prefer to add the equations like you were taught on yesterday's video. But it is possible to subtract them. However, to me, it just makes it more difficult. So we're always going to add them. Okay? And you'll start to pick up on that as we go. Okay, so the first thing that we're going to do is look for the variable that can be eliminated. Which variable up there can be eliminated? The y. And why can we eliminate the y? They have the same number, but they have opposite signs. Okay, to eliminate a variable, the variable has to have the exact same number beside it in the coefficient place, but opposite signs. Once you know that a variable is ready to eliminate, you simply add the two equations together. What is 5x plus 3x? 8x. What is negative 2y plus 2y? Which eliminates. And then what is 12 plus 36? 48. Okay, so now you have 8x equals 48, and you're trying to solve for x because that's the remaining variable. How do you solve for the x? Divide by 8, and so x equals 6. Okay, now is that the final answer? Correct. We have to have an x and a y value. How do I find the y value? Correct. I plug it in where? I plug it in the x. Now, you can choose either one. Do y'all want to work with the top one or the bottom one? Okay. I just would have gone with the bottom since it was all positive, but we can do the top. 5x minus 2y equals 12. But instead of writing the x, can't we replace the x with 6 since that's what we know x equals now? Okay, this will now become what? 30 minus 2y equals 12. And now to solve for y, what do we do? And so negative 2y equals negative 18. And now to solve for y, what do we do? Divide by negative 2 on both sides, and you get y equals 9. Positive 9, because a negative divided by a negative is a positive, and 18 over 2 is 9. Now remember, you write your final answer like an ordered pair. X comes first, so 6 comes first, and then 9 is second. And that's how you write your answer. Somebody has requested that I do the same thing, but with the bottom equation. Okay, well watch. I'm going to do it a little different. I'm going to rewrite that bottom equation. But instead of solving for one or the other, I'm going to plug the 6 in for the x and the 9 in for the y. So 3 times x, which we know is 6, plus 2 times y, which we now know is 9, equals 36. Everybody in here type in 3 times 6 plus 2 times 9 and tell me what it says. Type it in. Okay, and so that verifies for you that you did it right, that you do indeed have the correct x and y value, because when you plugged it in the bottom equation, it made it 36. What do you think would happen if you plugged in a 6 into this x and a 9 into this y? What would it equal? It would equal 12. That is the only x and y value that exists that would make both equations work. Okay, so think about it. With multiple choice, couldn't you just sit there and plug in all 4 ordered pairs that were listed into both equations until you found the one that worked? Now, that's going to take some time. So it's really better just to learn how to do the elimination method. But if you don't know how, or if you're getting confused, you just sit there and plug in each of your 4 choices into the x's and the y's and see which ordered pair makes a 12 and makes a 36. Okay, now we are going to continue working on yesterday's lesson. So I'm about to hand out a note sheet. To write this example on your note sheet that you just received. X minus 9y equals negative 15. And negative 11x plus 3y equals negative 27. Okay, so that is the system that we're trying to solve using elimination. Now, yesterday, step 1 just said identify the variable that can be eliminated. But when you look up there, is there a variable, an x or a y, that can be eliminated? No, because look, the x has what number beside it? An understood positive 1. But this x has a negative 11. Those are not going to cancel out when we add them, correct? And then the y has a negative 9, and this y has a positive 3. So those are not simply going to cancel out. Tyler, can you please pay attention? Those are not going to cancel out when you add them. Say that you were a magician and you could make any number appear that you wanted to. What would be nice? Okay, how could a 2 help us? An 11. It would be nice if an 11 were sitting right here, correct? Well, you can make that happen by multiplying the entire top equation by an 11. Okay, now watch me do that, and then you can write it down. 11 times x is 11x. 11 times negative 9y is negative 99y. And then 11 times negative 15 is negative 165. Yes. Yes, because you're being consistent. You're doing it to the entire equation. You multiply by any number you want. Yes? Because there's already a negative 11 on the bottom. Okay? We wanted to do that because we want to be able to eliminate a variable when they're added. And if this was a positive 11, since that's a negative 11, they would cross out. So to make that a positive 11, you just multiply it by positive 11. But you have to do the entire equation by positive 11, which is what we just did. Now the bottom equation remains the same. We're not changing it up. Now that we see a variable that can be eliminated because they have the same number but opposite signs, you just simply add them. Okay, which is what I'm going to do. So, what is 11x plus negative 11x? 0x, which does not have to be rewritten, so that's eliminated. What's negative 99y plus 3y? Negative 96y. And then equals, what is negative 165 plus negative 27? Negative 192. Okay, now we need to finish by solving for that y. So what do? Divide by negative 96. Negative 96 divided by negative 96 is positive 1. So that leaves y by itself. And then what's negative 192 divided by negative 96? Positive 2. So you are halfway done. You have your y value of the system. We now find the x value the same way we did yesterday. We take one of the original equations. Which one do you want to work with? The top? Okay, so the top is x minus 9y equals negative 15. But there's no need for us to keep writing a y when we know what y equals. It equals 2. Now we just simplify and solve. That becomes an x minus 18 equals negative 15. And now to solve for x, what do? Add 18 on both sides. And so x equals 3. Okay, now that you have your x and your y value, you write your ordered pair. What number comes first? The x, which is 3, and then the 2 comes second. So that's your answer. Now in your calculator, type in the second equation. So type in -11 times 3 plus 3 times 2 and see if it really gives you a -27. Okay, and so that's how you could do these on a multiple choice test. If you didn't know how to do it by elimination, you could just take each answer choice and type them in. However, is it okay if it just works for one equation, not for the other? No. To be a solution to this system, it has to work in both equations. So now type in 11 times 3 minus 99 times 2 and see what you get. You're not giving people, if you're not going to type it in, just stay quiet because they're actually trying to type it in. Okay, now flip over to the back of your note sheet and we're going to do example 2. Okay, example 2 is 2x plus 6y equals 0 and x plus 3y equals 0. Okay, step 1 says identify the variable that can be eliminated. Can the x's be eliminated right now? No, because that's a 2, that's a 1. So not only are they not the same coefficient, they're also not opposites, they're positives. Can the y be eliminated? No, because they don't have the same coefficient and they're also not opposites. What number would you like to appear and where? Right, it would be nice if this were a -2 sitting right there, correct? You can make that happen by multiplying the entire bottom equation by -2. That does not affect the top equation. The bottom equation will become what when multiplied by -2? Right. Right. -2x minus 6y equals 0. Now that you have a variable ready to eliminate, you add them. And correct. You will notice that not only do the x's eliminate because they're the same number in opposite signs, but so do the y's. Now remember, you can never leave a side blank. So at this point, you have to fill it with at least a 0. And then on this side, it equals 0. Is that a true or a false statement? True. 0 equals 0, right? Anytime you end up with something like that, but it is a true statement, that means there are infinitely many solutions. Yep. Okay, so write that down, and then I'm going to show you why there are infinitely many. Right, it gives you a true statement. Okay, does everybody have that written down? Okay, you don't have to do this, but I just want you to watch me take both of those equations from that system that we just solved by elimination. I'm now going to solve them by graphing, so just watch. This is the mx. It belongs over here, so I'm going to subtract it on both sides to get it over there. It cancels out on the left, leaving 6y. And on the right, 0 minus 2x is just -2x. We now divide by 6 on both sides, and y equals -2 over 6x, or won't that reduce to a -1/3 x? Okay, so this equation has been rewritten in slope-intercept form, and it became y equals -1/3 x. I'm going to do the same thing to this equation. Hold on. This is my mx, so I'm going to subtract it to get it to the other side. This now becomes 3y equals 0 minus x, which is -x, and isn't that a -1x? I now divide by 3 on both sides, and don't I end up with the exact same thing? When your equations are exact, like their m and their b are the same, won't it be the same line coinciding? which is why there's infinitely many solutions, because they touch forever. They're on top of each other. Does that make sense? So is everybody understanding that you can solve these systems by graphing or elimination and get the same answer? You're just choosing the method that works best. Like, there's no reason to take the time to try to rearrange these and graph them when you can do elimination, which is a little bit easier when they're in this format. There's also another way to solve them that you learn in middle school called substitution, but we're not going to do that this year. It's just not in our curriculum. It was a middle school curriculum. I don't know. Okay, now let's try example 3. All right, example 3 is negative 5x plus 7y equals negative 19. And then the second equation of the system is negative 4x minus 10y equals positive 16. Okay, step 1 says identify the variable that can be eliminated. To be able to eliminate a variable, what do you have to have? What do you have to eliminate a variable? Opposite signs, but same number, right? Well, do the x's have either? No, they're not opposite signs. They're both negative, and they're definitely not the same number. The y's don't have the same number, but they have opposite signs. So I'm leaning towards eliminating the y's. But before that can happen, we have to make them the same number. Well, can you simply multiply the top equation by something to make that 7 become a 10? No. So this is one of the types where you have to multiply both equations by number. Okay, think about it. Couldn't I multiply that top equation by 10? Because 10 times 7 will become a 70. And then if I multiply the bottom equation by 7, 7 times negative 10 will make a negative 70. And then they will be able to eliminate because one of them will be positive 70 and one of them will be negative 70. Okay, but remember you have to multiply everything. So what will the top equation become when it's multiplied by 10? Right? And what will the bottom equation become? Negative 28x minus 70y equals, I think it's 112, right? 112. Okay, now that you have a variable that's ready to eliminate because it has the same coefficient but opposite signs, you add them. Okay, when you add negative 50x plus negative 28x, what do you get? Right? When you add a 70y plus a negative 70y, what do you get? 0y, so that one eliminates, you just mark it out. And then when you add negative 190 plus 112, what do you get? Negative 78. Now to solve for the x, what do we do to both sides? Divide by negative 78. And so those cancel out, and x equals a negative over a negative, which is a positive, and 78 over 78 is 1. Okay, so we're halfway done. We have the x value of our system. Now we have to find the y value by plugging back in. Which original equation would you like to plug back into? Top one? Okay, negative 5x plus 7y equals negative 19. Okay, there is no reason, though, to continue writing an x when you know x equals 1, so replace it with a 1. And now simplify and solve for y. What does this become? Negative 5 plus 7y equals negative 19. Now what do we do? Correct. We're trying to get everything away from that y, so we start by adding the 5 to cancel it on this side, and then we add it to this side And we end up with 7y equals negative 14. And then what do? Divide by 7 on both sides, so y equals negative 2. Okay, now that you know your x and your y value, you write your answer as an ordered pair. So the answer would be 1, comma, negative 2. If you feel like you know what you are doing, you can now flip over to the back of that worksheet, page 6, and start working those. If you are still confused, I'm going to work number 11 on the board and you can continue watching. Okay, so if you're still confused, I'm about to work number 11 on the board so you can continue watching. Otherwise, you can start working on your own. All right, number 11, we have 6x minus 7y equals negative 18. And then we have 2x plus 3y equals negative 6. Okay, when I'm trying to decide which variable to eliminate, my eyes immediately go to the y because I'm like, oh, we already got opposite signs. However, there's no easy way to multiply this equation and make 3 become a 7, correct? So instead, I should probably try to make this number a what? A negative 6 though. Okay, because if that's the positive 6 up there, doesn't this need to be a negative 6? Well, what would you need to multiply the bottom equation by to make that 2 become a negative 6? Negative 3. Okay, the top equation is not affected because we didn't multiply it by anything. The bottom equation is all multiplied by negative 3, making that a negative 6x, which is good because that's going to eliminate in a minute. That a negative 9y, and the constant a positive 18. Now that we have a variable that's ready to be eliminated because it has the same coefficient but opposite signs, you add them up. 6 plus negative 6 is 0, so it eliminates. Negative 7y plus negative 9y is negative 16y. And negative 18 plus 18 is 0. Now to get the y by itself, you divide by negative 16. Those cancel out, leaving y by itself like we wanted. And 0 divided by anything is 0. Okay, now that you know your y value is 0, you simply choose one of the equations. I'm going to go with the bottom one. And you replace the y value with a 0. So it'll become 2x plus 3 times 0 equals negative 6. 3 times 0 is 0, so just cancel it out. And now to solve for x, you divide by 2, and so x equals negative 3. So the final answer would be rewritten as negative 3, comma 0, which is choice C. All I did, I plugged in 0 for the y value, and then I multiplied by 3, which canceled it out because 0 times anything is 0. That brought down the 2x and the negative 6. I then divided by 2 on both sides, and that's how I got negative 3. Yes? Yes. Now, were you talking about up here? Yeah, I wanted, for these to be able to cross out, I needed this to be a negative 6. So to make a 2 a negative 6, you just multiply it by negative 3. Okay, do y'all need me to work one more? Okay. Number 12. All right, number 12. We have 12x minus 3y equals negative 3. And we have negative 6x minus 8y equals 30. Okay, my eyes immediately go to the x variable because they already have opposite signs. This is a positive, this is a negative. To be able to eliminate, you've got to have opposite signs, and those are not opposite. Then you're going to have to multiply one of the numbers by negative. Okay, if I multiply the bottom by a positive 2, then won't this become a negative 12x, and then it'll cancel out with that positive 12x? Okay, so the top is not affected. The bottom, when multiplied by 2, will become a negative 12x minus 16y equals 60. Don't forget, you even have to multiply that by 2. Now that I have a variable that has the same coefficient but opposite signs, I'm ready to eliminate by adding. Okay, so 12x plus negative 12x cancels. Negative 3y plus negative 16y becomes negative 19y. And then negative 3 plus 60 becomes 57. Now to solve for y, what do? Divide by negative 19. And so y equals negative 3. Okay, now that we have the y value, how do we find the x value? Okay, you want to use the top equation or the bottom? Okay. Okay, so we're using the top equation. But look, instead of writing y, can I now replace y with what it is, negative 3? So 12x minus 3 times negative 3 equals negative 3. That becomes 12x plus 9, because the negative 3 times the negative 3 is a positive 9, equals negative 3. Now what do? Subtract 9, and I get 12x equals negative 12. And yes, now I divide by the 12 on both sides, so x ends up equaling a negative 1. Right here. This? No. You're trying to get everything away from the x, so you're moving stuff away from the x. Okay, so your answer is negative 1, negative 3, which is choice D. Okay, you need to continue working on these problems by yourself. There's number 11. Right there. Okay, number 20. Hold on. Are you done with number 11 yet? You probably have done something wrong. Yeah, don't forget to multiply every single number by even the equals number. You might want to look back at it because you've done something wrong. 12 what? Yeah. Okay, let's look at number 20. Shh. Okay, number 20. We have negative 42x minus 54y equals negative 12. And then we have 49x plus 63y equals 14. Now, either one of them can be eliminated because the x's have opposite signs and so do the y's. However, is there any easy way to multiply by one equation to make it match the other one? No, you can't multiply this by anything to make it a 49, and you can't multiply this by anything to make it a 63. So, we are going to have to multiply both equations. Okay, so we need to sit here and figure out, like, what will a 42 and a 49 become? Or what would a 54 and a 63